Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. The starting material is an indene derivative where the 5-membered ring is fused to a benzene ring. The 5-membered ring contains a double bond, C2 is equal to C3 in the cyclopentene portion, and an OR group on C1, the carbon directly attached to the benzene ring at the ring junction adjacent position. Moving on to the next step. BH3 adds to the double bond in an anti-Markovnikov, SYN fashion. The boron, electrophilic, adds to the less substituted carbon, and the hydrogen adds to the more substituted carbon. The subsequent H2O2 oxidation replaces B with O with retention of configuration. Moving on to the next step. Apply the hint about positive charge stabilization. During hydroboration, BH3 acts as an electrophile approaching the double bond. The transition state has partial positive charge developing on one carbon. The carbon adjacent to the OR-bearing carbon, C1, which bears an oxygen substituent, can stabilize positive charge through lone pair donation from oxygen, oxocarbenium-like stabilization. This means the partial positive charge preferentially develops on C2, the carbon closer to C1, or, so boron, electrophilic, adds to C3, the carbon farther from OR, and H adds to C2. And for the final step, boron adds to C3, IChO carbon, away from OR, hydrogen adds to C2, carbon adjacent to C1 OR. After oxidation, OR replaces B at C3. Wait, re-examining, the OR is at C1, ring junction carbon adjacent to benzene. The double bond is C2 is equal to C3. The developing positive charge is stabilized at C2 by the adjacent C1 OR group oxygen lone pair donation. Therefore, electrophilic boron adds to C2 and H adds to C3. After oxidation, OR is placed at C2 adjacent to C1 OR. The product has the indene skeleton with OR at C1 and OR at C2 both on the same face, SYN addition. This corresponds to option B, indene with OR at C1, adjacent to benzene ring, and OR at C2 of the 5-membered ring. Option A would require OR at C3, Markovnikov-like addition, wrong regiochemistry. Options C and D show incorrect regiochemistry or additional substituents not consistent with simple hydroboration oxidation. Therefore, the correct answer is B. Therefore, the correct answer is option B.